This conference will now be recorded.
So last class, so mainly we discussed about, we're having some Hadoop process names. So namely name node, data node, second name node, job tracker, and task tracker. Okay, if you're going with Hadoop 1.x, if you're going with Hadoop 2.x, so job tracker is replaced with resource manager and task tracker is replaced with node manager, right? And if you go with a Hadoop, we're having two components. One is HDFS and MapReduce. So within the HDFS, so which first names comes under HDFS here? Nothing but name node, data node, and second name node. So these process names related to HDFS. And now if you go for MapReduce, so resource manager and node manager. So nothing but it is related to MapReduce, right? So, and even we had discussed about what is exactly, what is exactly name node means, what some small information about name node, what it is exactly doing, name node, data node, second name node, job tracker, task tracker as well, right? So if you observe the name node, so main it is storing the metadata, data node storing the actual data, and second name node, backup of name node metadata, but not for process backup, okay? And job tracker just assigning job tasks to task tracker. I think, but just is going to assign some tasks to the task tracker. So what about the task tracker? Task tracker responsibility is nothing but to execute the task, whatever the task which is assigned by job tracker, and finally it need to send response back to the job tracker. So these information we discussed already. And one more thing is we discussed is RPC port and HTTP port. What is exactly, RPC, being but remote procedure calling, and HTTP port as well we discussed here. And for each and every process names, we're having a separate HTTP port, and RPC we're having only for name node and job tracker. And we have given some example what is exactly RPC communication and this HTTP port. So we have given some example called as nothing but Axis Bank. So we have mapped with our RPC port and HTTP port as well. And after that, we discussed about some architecture overview. So nothing but name node, second name node, job tracker, and data node, task tracker. How within, if for suppose if you're going with a cluster, so within the cluster, how it is going to look like. So we discussed these all these things, and mainly it is having we have some points as well. Nothing but Hadoop is a master slave architecture, and it is followed by some RPC communication and heartbeat mechanism for every 3 seconds. How name node is going to know which data node is down or which data node is up? That is nothing but by using a heartbeat mechanism. So this mechanism is going to happen for every 3 seconds, so that name node is going to know which data node is up and which data node is down easily. And even we had discussed a small concept called as a data locality. So Hadoop by default follows data locality here. So nothing but wherever the data is there, there only we have to process it or execute it. Okay, so these points we discussed clearly. And we discussed an important point called as, so why second name node is not acting as a process backup, just it is storing only metadata backup only. So that point also we discussed here. Uh, I think these things were discussed, and after that, I think we have started about design of HDFS as well, right?
This conference will now be recorded.
So these things we discussed here. So if you're having any queries or any doubts, so let me know so that we can discuss. And let me continue further with design of HDFS. Uh, if you go with the design of HDFS now, design of HDFS. So first point is storing the large amount of data or large files. So, and here we discuss the three concept already, nothing but block size, replication factor, and one more thing is what we call metadata, right? And the second one, streaming data access. Streaming data access. So that is nothing but write once, read many. Write once, read many. Okay. So best example is YouTube. So if you observe the YouTube, just we are uploading only one time, but we are viewing the n number of times. There's nothing but write once, read many. Same followed by HDFS as well. Okay. So once if you store some file within the HDFS, so you can read n number of times, or you can view that a particular file in n number of times based upon your requirement. But we are writing only one time. Okay, nothing but what is exactly write once and read many. And last one is nothing but commodity hardware. So commodity means nothing but inexpensive hardware. Okay, so here if you observe the architecture, so I have mentioned I mean at previous class I had discussed some architecture. So if you observe within a single machine, I have mentioned two process names. One is data node and task tracker, right? So here, if you observe this data node and task tracker, so nothing but these things. Hadoop point of view, we're calling as in data nodes, right? But generally, these are things also nothing but a machines or nodes. So these data node and task trackers, right? Nothing but where the data is stored exactly. Thing but first of all, if you observe this name node and data node, name node is going to store only metadata. But what about the actual data? Means first of all, whenever if you're storing a file inside of HDFS, so Hadoop is dividing that respective file into n number of blocks based upon our block size. And these blocks they are storing in a multiple data nodes and followed by replication factor. This concept we discussed already, right? So now here, if you are storing in a multiple data nodes, which is followed by task tracker as well. So these data nodes we can follow with a commodity hardware. Nothing but we can make it as in 500 GB RAM. Sorry, 500 GB hard disk and 4 GB RAM. That is sufficient. Okay, because even if the system is down, so we are maintaining the replication pattern. So there is no chance of losing the data as well. That is the reason Hadoop itself, HDFS itself, it is following the commodity hardware. So, and after that, we have started about the thing but drawbacks in HDFS, right? So, one is low latency. Low latency, data access is not there. Okay, low latency, data access is not there. So, here what is exactly low latency? Okay, so for example, so we have a SQL query. So, I think most of you have some basic knowledge on SQL. Okay, so if not, we will discuss. Okay, so let's start from student. So assume that we're having a database name as a student DB. Okay, within that student DB, we're having a couple of tables. So one of the table is student, where student ID equal to some 2000. Okay, so now within this student table, just assume that we're having some 10,000 records. Okay, we are having some 10,000 records. So whenever if I execute this query, select star from student where student ID is equal to 2000. So what is going on internally? Okay, so nothing but how this SQL is going to process this particular statement. So first of all, it will check all these 10,000 records, what are the records uh, which is having this respective table, student table. Within the student table, we have assumed that 10,000 records, right? So it will check each and every record. It will check each and every record. So once if he got that, once this SQL engine got this 2000 record. So then it will retrieve that respective values. So assume that within the student table we're having some couple of columns, right? Nothing but student ID, student name, student number. So like this, we're having some couple of columns which is having some values, right? So for this student ID which is having a 2000, so it will retrieve all the values. But if you observe this process, it will be gone within the fraction of seconds, but it will not take huge time, right? But for suppose if you're having some 1 lakh records or 1 million of records in the maybe some you can take it as a MySQL, right? So then whenever if you try to execute this statement, it will take some couple of minutes as well sometimes. Okay, maybe some will take some 2 minutes, 3 minutes, 5 minutes as well. So whenever this data, I mean, whenever the records is grown, whatever the records which you are having, right? So day by day, these records is growing means definitely performance is going to affected. Performance of the application will be affected. So nothing but here, if you observe this style star from student by student is equal to 2000, this is nothing but a file level indexing. So we don't have the content level indexing in the SQL databases. Doesn't matter what is exactly low latency. Means whether the data is small or large. For suppose if you're going with a MySQL, right? I'm storing some 10 GB or 1 terabyte or 10 terabyte, 2 terabyte, 30 terabyte, or 1 petabyte of data, irrespective of data. You can say that irrespective of data. So once if you fire a query, so immediately I need to get the results. But that concept, I mean, that mechanism we don't have within this HDFS here. But what is exactly low latency? Within the SQL, we are having only content file level indexing is there. We don't have the concept of content level indexing. Then nothing but what is exactly low latency. This is the best example. Okay, so this I mean this is the same problem we're having in the HDFS HDFS also is there. Okay, so we can overcome this limitation. Okay, what are the limitation we are facing in HDFS? So this limitation we can overcome by using this limitation we can overcome by using NoSQL databases. So we're having so many NoSQL databases. If you anybody having idea, so popular is some MongoDB, Cassandra, okay, CouchDB, okay, and if you observe the Hadoop point of view, right? So we're having some HBase, which is a NoSQL databases. So by using this ecosystem, okay, so we can overcome this limitation. Okay, what are the limitation we are facing? Okay, that is a one limitation. And second limitation, nothing but multiple writes and arbitrary modifications are not allowed. Okay, multiple writes and arbitrary modifications are not allowed here. Okay, so what is this exactly? Or simply we can say that we don't have the concept of update. No updates in HDFS. So for suppose if you're showing some first.txt which is having some 1,000 lines within the text file, we're having some 1,000 lines, right? So now I want to add a one more line. So is it possible within the HDFS? Means it is not possible here. We are unable to update whatever the files which are already stored in inside of HDFS. Before storing, if you want to update that a specific file, you can. But after storing, if you want to update, we are unable to update a particular file, right? So and even we have discussed some diagram as well, if you remember in last class. So here we're having some digestion, we're having some 1000 blocks like B1, B2, B3, and here nothing but 1000 blocks. Okay. So assume that each and every block says nothing but it is following a default block says and nothing but a 64 MB. Okay. So now here I'm trying to add a 1 MB, 1 MB of data. So I'm trying to add 1 MB of data. Okay. So here it is already 64 MB, right? B1 block says is already 64 MB. We're unable to add this 1 MB of sorry, we're unable to add the 1 MB of data, even this B1, B2, B3, because already it is having a 64 MB. Size itself, nothing but by default blocks itself 64 MB. So beyond that, if you are able to add, nothing but we are unable to add this 1 MB of data. Okay, so that is the reason Hadoop, instead of following this, updating concept, right? Because if you want to update this block, right? So we need to update this n number of blocks. Okay, each and every block it need to check. Okay, where it is, where this 1 MB of data is going to be fit. Okay, nothing but even though if you want to add this 1 MB of data inside of this B1 block or B2, B3, so or even maybe some B99 or maybe B999 block. So we need to check. Hadoop itself, it need to check. It need to check or it need to update the n number of blocks, which is again it is going to affect the application performance, or we can simply say that it will dictate the performance. So that is the reason. So if you want to add this 1 MB of data, so try to add this end of this 1000 blocks. Hadoop is going to add at the end of this 1000 block. We no need to do any manual work or we need to do any programming. So Hadoop by default is following. Okay, so we don't have the update concept. Instead of update, we're having the concept called as an appending. Okay, so let us summarize some points. So if we are adding or removing data, n number of n number of blocks has to be updated. Okay, so it will degrade the performance. It will degrade the performance. So if you are adding, so Hadoop supports only appends, but not for updates. Okay, Hadoop supports only for appends but not for updates. Okay, so is these points are clear, all of you till now? What are the points we discussed here? Is it fine? Any doubts? So on one more last limitation, lots of small files is an issue. Okay, lots of small files is an issue. So means, I have mentioned you one important point. So name node is always going to store metadata. That point is very clear to us. Okay, name node always going to store only metadata. Nothing but where and all blocks are present in a multiple data. So we're having some three machines. N1 is having some B1, B2, B4 block. N2 is having B3, B4, B5 block. N2 is having some B6, B7, B1 block. So this is nothing but what is exactly metadata. This information, so in Hadoop point of view, where it is exactly storing. So we are having a process name called as a name node. So name node is going to store this entire information, right? This point is very clear to us. Okay. So now here lots of small files is an issue means, okay, first suppose just assume that I'm storing some 1 million of small files. How many? 1 million of small files. Okay, so just assume that each file it is taking one 64 MB as a block size. Okay, each file it is taking 64 MB as a block size. So 1 million files means how many blocks we're going to get it here? 1 million of blocks, right? So if it is a 1 million of blocks means how much metadata is going to increase? Nothing but it is indirectly pertain to the name node once again. Okay, so whenever if you're having a lots of small files, so we're having say we're having some 1 million of small files, right? Whenever if you're storing this 1 million of small files, metadata is going to increase rapidly. It is again button to the name node. Maintaining of this much of metadata is again button to the name node here. So whenever if you're having a lots of small files, so what we need to do in real time is, so just make this all these files as a some we can say it as a, some rare or zip files or war files. Okay, so I'm having 1 million of small files. Just assume that each file is taking some, let us assume 1 MB. Nothing but 1 million of MB is there, right? Instead of storing each and every file inside of HDFS, try to make these all files as a single file and try to store it in HDFS. Now, what is the advantage is whenever if you're following this approach, it will reduce the metadata or not. Okay, I think but it will reduce because we are storing in a single file. So it may be some maybe some 8 blocks or 10 blocks. Instead of 1 million blocks, we're getting only 8 blocks or 10 blocks. So that metadata is going to reduce and it will not be buttoned to the name node as well. So is this point is clear, all of you? First of all, let me know. Is it clear? What are the point which I explained you? Okay. Otherwise, let us go with some table structure. We're having some file size, block size, number of blocks, metadata size. So if it is file size is just assume that 1 GB, block size is 64 MB. So how many blocks is required here? Nothing but 16 blocks. Metadata size is, let us assume it is 1 KB. Okay. So we're having file size as a 64 MB, block size as a 64 MB again. How many blocks? Only one block. Metadata size is, my laptop is very slow. Okay, so now here 1 MB, so 64 MB as a block size, right? How many blocks here? Again, one block. 1 KB as a metadata. So if my file size itself 1 KB, okay, block size is, it is by default 64 MB, number of blocks is 1. So metadata size is 1 KB. Okay, now if you observe here, you're going to get a complete picture. So remove these things. Okay, you don't need to worry about this one. But if you're going with the 1 KB, okay, so let us assume we have 1 KB files. Okay, around some 10,000 1 KB files is there, and each file it is storing in one block. 64 MB. Okay, nothing but we're having some 10,000 blocks now. Okay, how many blocks here? 10,000 blocks, and each block it is going to replicate into 3 times, right? Nothing but we're having a concept called as a replication factor. 10,000 into 3, nothing but total we're having a 30,000 blocks is there, right? So 30,000 blocks means, so how much metadata is going to have? So here we have taken as a, for 1 KB we have taken as a 1 KB as a file size, metadata size we have taken as a 1 KB, nothing but 30,000 KB metadata size. So it is very, very huge, and it is huge burden to the name node here. Okay, so that is the reason whenever if you're having some lots of small files, whenever if you're having a 1 KB files, so make this, if you're having some 10,000 KB, okay, 10,000 1 KB small files as around 10,000 files, make all these 10,000 files as a single file or multiple files. Maybe some you can make it as a 10 files, 10 war files or 10 zip files. Okay, try to store these zip files or wall files inside of Hadoop, inside of HDFS, so that metadata size is going to reduce, and it will not be a burden to the name node here. Okay, so this is a one limitation we're having, and again we're having a solution also. Solution is, whenever if you're having a lots of small files, so try to make it as a single file. Okay, by using a different techniques, either war files or zip files, and within the Hadoop we're having so many compression techniques is there, so which we'll go and discuss later. Okay, we can use any of these mechanisms. Okay, I hope this point is clear now, all of you. Okay, clear?
Sorry, sure. Actually, what is this? While we are splitting this, what is the metadata size 1 KB? I'm sorry.
Metadata,
Why it is only
sorry, I
1
did
KB?
not get you. No, just to have assumed. Okay, to explain this information, to explain this theory point, I have made it as a 1 KB as a constant value.
Oh, okay.
Okay, it is not a not a fixed one. Okay,
Okay.
for explanation only I have taken. Clear, Suresh?
Yeah, sure.
Okay, fine. I hope this point is clear, this concept is clear, all of you. Okay,